The manufacture of automobiles is characterized by continuous technical and organizational changes. Innovations keep overtaking each other with ever-increasing speed. The market dictates the requirements for the development of the next generation of automobiles. Among these are shorter product life cycles as well as more stringent requirements with regard to safety, comfort, environmental protection, and fuel efficiency of the vehicles. From many points of view, modern production technologies can be a valuable contribution to achieving such high goals. Material consumption can be reduced to produce lighter weight structures. Additional functions can be integrated into one single component, and development times and costs may be reduced. Against this background, one production method lately has had considerable impact on the fields of body-in-white, chassis, and exhausts. This is hydroforming. For hydroforming applications, Schaefler Hydroforming has developed process technology. The production system shown here, manufactured by Schaefler Hydroforming, is the first of its kind in the world. Fully automated, this line produces tubular engine cradles for passenger cars using the hydroforming method. This production line is a core piece of an expansion investment plan presently in progress at the GM Opel car manufacturer in Bochum, Germany. Starting from an approximately 8.5-foot long straight tube as raw material up to the completed engine cradle, all related operational steps regarding production and quality assurance are integrated into the production system, and the interface points are fully automated. The actual manufacturing process within the system is subdivided into the following operational steps: bending of tube, preforming of tube, hydroforming and hole punching of tube, tube ends machining, washing and drying, automatic transfer of components to standby dollies. In order to harmonize the individual cycle times, 2 tube bending stations and 2 hydroforming units were required. On the loading side, the line is loaded by a forklift. A special loading system is provided to fill the storage magazines of the tube benders. These are arranged at right angles to each other. Each storage magazine can hold approximately 200 tubes, which is equal to approximately 1 hour of production. A swiveling arm feeds the tubes individually from the storage magazine to the tube bender. A weld seam orientation device positions the tube in such a way that during bending, the weld seam is located in the neutral zone. During the bending operation, a laser scans the bends being produced for possible cracks in the material. If a crack is found, the part will be automatically rejected by the transfer robot. A robot transfers the bent tube out of the bender. Position sensors provided in the robot gripper verify the geometry of the component. If the position of a limb of the bent tube deviates by more than 2 millimeters from the previously defined reference position, the part is rejected. Prior to the actual hydroforming process, a separate pre-forming press produces a component contour which optimizes the subsequent operations and, as a result, the productivity of the line. The pre-forming press has a pressing force of 200 tons. Once the bent tube has been loaded into the press, sensors verify its correct position. Thereafter, the tube is vertically compressed by the ram force and horizontally by punches within the die. The process itself, as well as the production result, are monitored by a digital position control loop and initiators. 2 robots transfer the preformed tubes from the preforming press to the 2 subsequent hydroforming presses. Before the tube is loaded into the ASE hydroforming press, the robot carries the part through a lubrication station which is arranged at the side. Here the tube ends are sprayed with lubricant. This is necessary to optimize the material flow in the hydroforming die. Each of the hydroforming presses has a closing force of 3,900 US tons. A computer simulation illustrates the sequence of processing in the closed die. Axial cylinders move into the tube ends and seal the tube hermetically. While the die is closing, the forming medium with a base of water and additives is injected through the inlet ports. The high-pressure unit builds up an internal pressure of 22,000 psi, and the component is formed. During the forming process, the axial cylinders compress material from the tube ends into the forming zone. The final shape of a component is predetermined by the internal contour of the hydroforming die. Forming completed, punches produce a total of 22 holes against the internal pressure. The resulting slugs are not cut off completely, but folded back. The forming process is monitored by 4 control loops. The control of press stroke, pressurization in the tube, pressure intensifier, and axial cylinders ensures the quality of the finished component. A deviation from the nominal dimensional values will cause the part to be ejected by the unloading robot. After the hydroforming process, the ends of the formed engine cradle are machined in a separate station. Sensor pins which are provided in this station verify that all 22 holes have been punched. If a hole is missing, this is obviously caused by a die fault and production stops automatically. In 2 subsequent operations, holes with a diameter of 50 millimeters are first punched, then the ends are cut. Sensor pins verify the faultless completion. A potential die fault, as mentioned, will lead to an automatic stopping of the line. On completion of machining, the engine cradle is transported by a chain conveyor to the washing station. The washing station is divided into 5 areas. First, the engine cradles are washed, cleaned, and preserved with 3 different agents. Thereafter, residual liquid is blown off and the component is then dried in a drying area at 203 degrees Fahrenheit. At the exit side of the washing station, the engine cradles are packed in bundles of 14. 2 inclined conveyors and a turning device transport the cradles to dollies which have an underfloor drive mechanism. A transport train consisting of a total of 4 dollies, each capable of transporting 3 bundles of 14 cradles, is standing by. If one train is fully loaded, it will automatically cycle onto the pickup station. From there, the transport train moves on to the assembly area. Meanwhile, an empty transport train moves automatically into the transfer station. All components of the production line communicate with each other by means of 4 bus systems, these being centrally interfaced. From the central control desk, an operator-friendly synoptic allows analysis of the operational condition and potential faults in the line. The complete production line is run by only 2 operators. For noise reduction and easy maintenance, the main drives of the presses, as well as the high-pressure units for hydroforming, are installed below floor level. The high-pressure hydraulic system is designed out for a maximum pressure of 59,000 psi. A combined analysis and top-up unit makes sure that the concentration and level of emulsion needed for hydroforming is kept constant at all times. A multi-stage filter system with coarse and double fine filters, as well as with an oil skimmer, guarantees the necessary purity. With this hydroforming line, Schaefler Hydroforming has set new standards for large batch production of structural parts in the automotive industry. The cycle time for one part is 15.9 seconds. With a 5-day, 3-shift work week, 1 million engine cradles are produced by the system per year. The engine cradles, previously produced by the half-shell method, can now be manufactured in one single piece. As a result, the weight of the component has been considerably reduced. The modern concept of the engine cradle, combined with related parts, assists in facilitating the future-oriented modular building systems in the field of drive and power transmissions. All the advantages described will help its end user to increase his competitiveness. From the first feasibility study to component and process development, up to delivery of a complete manufacturing system for large batch production, Schaefler Hydroforming is your innovative system partner for hydroforming.